Hello everyone, we are Cornell University's Solar Boat, or CUSB. We consist of 25 active members from a variety of majors divided into 5 specialized sub-teams: hull, solar, system controls, drivetrain and steering, and finally business. We are beyond excited to compete in this year's Solar Splash competition, as we have worked tirelessly to get here. Since our last boat, we have made big strides to optimize our designs for an efficient and robust 14-foot-long solar-powered boat, in the hopes of improving our results from the last time we've competed.
The drivetrain and steering sub-team is responsible for designing and manufacturing the outboard transmission system and the steering system's mounts. This year, we focused on making the drivetrain lighter and more durable. Since 2021, we have completely redesigned the lower housing to better accommodate our bearings, radial shaft seals, and O-rings. We utilized a 1 to 1.167 gear ratio to power our optimized propeller for the endurance competition. We also redesigned our nose cone to reduce resistance. Many of our design choices were in an effort to prevent leakage, such as incorporating internal waterproofing to the upper housing and creating a 3D printed mesh wrap for our motor. We have all become more proficient in engineering skills such as CAD, finite element analysis, tolerancing, sustainability, structural analysis, and manufacturing. I'm extremely grateful to have worked with such a dedicated team of engineers. I am so proud of how far we've come. Despite being a small team, we have received significant support along the way, and I'm excited to see our work come to life.
So system controls has mainly been focusing on improving the electrical system, and this involved both increasing seamlessness and adding more functionality to the system. So that included a few things, like adding a kill switch or a contactor, motor testing, and creating new configurations, series and parallel, and longer wires, things of that nature. But we're also heavily focused on working with the other teams, the other sub-teams, so that the motor can work the best it can. This included working with solar to charge the batteries with the charge controller, working with drivetrain to thread the motor, and also working with hull to box all of our components.
We built a functional real-time data display, which provides our skipper with live voltage readings for our boat's batteries through the use of an Arduino, a tablet, a C++ script, and a few Python scripts. The voltage data acquisition system we have built works for both our series and parallel configurations of the batteries. This involved the development of both a backend, which was implemented using Flask and SQL Alchemy, and a frontend, which utilized many packages to visualize the data stored in our backend.
I think one of the most rewarding aspects of this process for me has been to see the real-world benefits of collaboration and to have the opportunity to learn and to lead by example. Our team includes freshmen through seniors across different engineering majors, as well as majors outside of engineering. And there's always an opportunity to learn from the skills and experience of my teammates. Now that I'm entering junior year, I feel I have even more of an opportunity to lead and to contribute through my own skills and example. I'm incredibly proud of the boat we were able to build together.
The solar subteam's focus is to build the best and most efficient panels possible. Our process starts in the design phase, where we discuss different possible panel designs for the year and make CAD renderings of what they would look like to develop guiding measurements. We then move to the solar cell level, sourcing the cells from suppliers. We spend work sessions soldering the cells together into chains, which we then use to make our eventual panels. We make our own panels so that they can be better integrated with the design of the boat. This year, our panels are 2 4x8 arrays and 1 3x9 array with foam backings, a Tedlar backsheet, and encapsulation via resin. In making our own panels, we allow for continual improvements each year, and our panels this year address specific problems that we have faced in the past, including poor encapsulation and a weak backing for the panel. Next year, we are excited to continue improving by creating smaller, more modular panels that will better integrate with the boat and implement a cooling system to allow for higher efficiencies. We have also developed new manufacturing techniques with EVA encapsulation to improve upon our existing process and moved away from resin to achieve a more consistent result with less weight. The solar subteam is composed of individuals excited about the mechanisms of solar technology, and we look forward to seeing our system in action at competition.
The current hull design features a displacement hull, optimized for endurance. It measures 14 feet in length, which reduces the overall weight by 20 pounds compared to previous year's designs. Simulations in ANSYS Fluent indicate that a sharp hull design would exceed expectations by generating a lower drag force. The hull is constructed with a foam core secured to wooden ribs and encased in fiberglass using polyester resin. Testing revealed instability due to the sharp keel and narrow beam of the boat, so therefore we decided to add pontoons to our hull to help it with balance. The bow was 3D printed and attached to the front of the frame and filled in with expanding foam to enhance buoyancy. The hull's underwater cross-section is approximately semicircular, designed with a low surface area to volume ratio to minimize drag overall.
I've seen great progress this year on this team despite the difficulties in the past, and I'm proud and excited of what is to come in the future. I truly believe CUSB is a team that fosters the growth mentality needed for sustainable solutions to current world problems. As we develop in the coming years, I believe we will continue to make our mark and pave the way for a sustainable future.